Okay, we're in Sage Projects, Math 122, Project B. Again, we're hoping that you're following along from actually the 119, but if you're not, if you've done Project A, you know how to create a Jupyter notebook and you know how to run the terminal. As I said in Project A, I like running the terminal better. So the first thing I want to do is just launch the terminal. Right now, my terminal is already running, but remember, if you need to launch a terminal, just launch Sage, and you're given a choice whether it's command line terminal application or a Jupyter notebook, right? Again, I already have it launched, so I don't have to launch it again, but you could launch it, and you'd have two instances of Sage running, all right? But it's already running. I already have my terminal running. And I want to point out what I mean by that. My terminal's running with Sage, all right? So what I want to do is I want to, emphasize how you're going to be doing these projects, right? One is you're going to try to read it and understand what you're given. So this Sage project is depending on how you long divide, and I really mean that. There's really kind of two separate ways to long divide. So I think the most typical way to long divide is the first case over here, 11. You would get this power series over here. Now, if you did it slightly differently, I certainly have observed students doing it differently. They get a different, although really not a power series because they're negative exponents, but the bottom line is still a series. You get a series out of it. Now, you would get series 12 if you divided it differently, all right? So someone says, how could that possibly be? Well, there's different regions of convergence for these guys over here. For example, this first one converges between -1 and 1, certainly not at 1, by the way. And the other one converges outside that band, all right? So what are they doing over here? They want you to take Sage out and run this code over here, but this code has a lot to do with this thing over here. So what I want to do is, part of your learning curve is understand what's presented to you, and then playing around with Sage to learn a little bit more about what's being presented to you, all right? So I'm going to go to my Sage, and I'm going to just move this up a little bit, and I'm going to move this over here and just start typing things in. Reset, return, and I want to do X as a variable, and reset gives me a clean sheet, so to speak. Gets rid of any leftover things that I had stored before. Now, X is a variable. Believe it or not, in Sage, X is automatically a variable. But I really think it's a good habit to get into is in defining your variables before you use them. I'm going to now assign f of x, which is a function now. I'm going to assign it 1 minus x to the power minus 1. Right, if I want to display f of x, I could do that, and I'm seeing that right over there. Now, someone says, what's this all about? It's this thing right over here. Now, I realize some people are looking at this and saying, oh, that looks much different. It's the same thing. They just write it differently, all right? It's the same thing. This is how we normally write it in classroom. This is how Sage would write it down on their instance of using Sage. So, what are they going to do? And I want to point out, they're going to do something, all right? So let me write this down for you. They write a new function down, g of x, and g of x is equal to a summation. And what's that summation going to be equal to? X to the nth power for n is a counter, by the way, n, and it gives me a range of numbers from 0 ... to 1,000. All right, let me hit return. And by the way, if you display g of x, let me do that for you, you get something that, an expansion of that. And again, somebody said, oh, that's crazy looking. I don't want that. I'm not saying you did want that. I just created that. So let me just clear the screen again. And I have a couple of things going for me at this point. I've reset, clean sheet of paper, anything that was stored in memory is kind of cleared out. I defined a variable x. I defined a function f of x. And I defined another function g of x, which is related to f of x. But this function over here is going to be a pretty good match of f of x, only in a certain region, by the way. All right? And now I'm going to divide h of x. I'll do that for you. And h of x is equal to minus the sum of x to the, minus n minus 1 for, n in 0 ... 1,000. Let me hit return. And you could display h of x too, but again, it's kind of unproductive. That's not really the point of it, but you get something that looks like this over here. So let me tell you what I've done over here, all right? Certainly we defined this function. I defined this one, but not for infinity, only going up from 0 to 1,000, all right? And I define this one over here. And again, not for infinity, only to 1,000. All right? That's pretty good expansion, by the way. Now what I want to do is I want to plot all three functions together. Let me go over that with you. And I'm going to clear the screen by typing in clear. Maybe you didn't see that because it was hidden. Clear. Please do not type reset because you'd lose F, G, and H now. And what I want to do is I want to plot. All right, so let's type that in. I'm going to type in plot, P-L-O-T, and I'm going to plot a list down. And the list I'm going to plot down, I'm going to use square brackets for the list, by the way. F of x, G of x, and H of x. Now again, if you're paying attention, f of x is our function. I said g of x would fit it between -1 and 1, and h of x would fit it outside of that band, -1 and 1. All right? Now, what do they want me to do? X min, and x min to be -10, they say. And you can play around with these numbers if you like. X maximum, that would be 10. And let's see, y min is -10, and y max is 10. And again, you can play with these numbers if you like. And let it return, and you'll see what something happens. And I get a picture. And so I don't understand what that picture is. And I want to tell you what that picture is. That's a picture of the function. And I granted, when you look at the function, say, I don't know what I'm looking at. By the way, I want to go back and I want to change the code a little tiny bit. All right? So what I want to do, I want to get rid of the h of x and the g of x. And I got this over here. Now someone says, what is this a picture of? I want to point out the picture of f of x. Now someone says, what's this line over here? It's an artifact. We can get rid of that line, by the way, by saying detect pole, and it would put a vertical asymptote in. I'm not too worried about that, though. And now what I want to do is, I'm going to close this picture out over here, and I'm going to close this one out as well. I'm kind of editing the code, by the way, and I'm going to put in the other one, which is going to be, let's see, what do we do? That was g of x, right? Comma g of x. So this is going to graph two pictures out on the same axis. And remember what I said about g of x? It's going to fit f of x only on the band between -1 and 1. Let's do that. And what do you get over there? I'm seeing it. I want to point out the blue curve is f of x. The green curve, which really kind of looks very strange over here, like vertical. All right? It's really not vertical, but it looks vertical. And it only fits it between -1 and 1. All right? Now let me go back and change my code. And I'm going to get rid of the g of x, and I'm going to put h of x. And again, we're just observing things. And I said this one's going to fit outside the band -1 to 1. And what am I seeing over there? Well, now the green curve is that other curve, which is h of x, is fitting outside the band. All right? It's fitting outside the band. Now, you may want to play around with this a little bit more. By the way, what I mean by that, if I want from, let's go from -100. This is the x values, by the way, to 100. Hit return. It's a really good fit, isn't it? I mean, you really can't tell the difference between the, what I mean by that, we're so zoomed out, we're not seeing what's happened near the origin. But on the outer bands, it looks like it's an impeccably good fit. It really does, all right? But again, part of this thing is learning. And what are you learning over here? One is, this is typical. This is a very, by the way, this series was introduced to you in Math 120. It's geometric. And this is the expansion for the typical expansion for geometric. And it's certainly done by long division. And most students doing long division, we get this one over here. But again, on occasion, I've observed students doing long division differently, and they get this series over here, by the way, all right? And what do we do over there? I just graphed them out. I'm seeing where they fit. That's all we're doing. We're seeing where those series fit. Thank you so much for paying attention.